Okay, today we're going to look at how to graph systems of equations. What you need to remember here is that it's just like graphing a regular linear equation. It's just that you're now putting two of these graphs on to one graph, or two lines onto one graph. So if you know how to graph a single line in y equals mx plus b form, you know how to graph systems of equations because you just do that twice. Okay, so essentially we're just going to take each of these equations, y equals negative 3x plus 10 and y equals x minus 2, and we're going to put both of them on this one graph. Okay, so what we first need to remind ourselves here is, how do you graph? Remember, you start at the y-intercept. Okay, so if we look at the first equation, y equals negative 3x plus 10, our y-intercept is 10. This is where we start. You start your graph at 10. So we go to our y-axis here, and we count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spots. And that's where we're going to start. That is our y-intercept of 10. Now, our slope, which in this case is negative 3, tells us where we are going to go using our rise over run. Now, negative 3 as a fraction is negative 3 over 1. That tells us that we are going to move down 3 because the top number is negative, and we're going to move to the right 1 space. So from where we started at 10, we count 1, 2, 3 down, and 1 over. There's our point. Now we do that again just to get a more accurate line here, and count 1, 2, 3 down, and 1 over. 1, 2, 3 down, and 1 over. And then we can take out something straight, and we can draw this line. Simple. Next, we look at the next equation, which is y equals x minus 2. Now in this equation, our y-intercept, or where we are going to start, is negative 2. We count here, this is our y-axis, we go down 2. We start there. This is the starting point for the second equation. Now our slope for this, because there is no number that is in front of x, it's assumed that that number is 1, which means that we are going to go up 1 and right 1. Rise over run. So we just count 1 up, 1 over. 1 up, 1 over, 1 up, 1 over, and we can draw that line. Now we're looking for if and where these two lines intersect. You can see that they do intersect right here. The point value, ordered pair where these intersect, is at 3, 1. So that is our solution. The solution to this equation is 3, 1. So how many solutions does this system of equation have? Because these lines only cross at one point, this has one solution. Let's try that process again with these two equations here. The first equation is y equals 2x plus 4. If we look, we're going to start this equation at 4. Start the graph at 4, so 1, 2, 3, 4. The slope is 2. As a fraction, that's 2 over 1. We're going to go up 2, right 1. Up 2, right 1. Up 2, right 1. Draw our line. That's the first one. Now we look at the second equation, y equals 2x minus 3. Start this one at negative 3. That's our start. 1, 2, 3. The slope again is 2. 2 over 1 means we go up 2 and right 1. Up 2, right 1, up 2, right 1, up 2, right 1. Take out something straight and draw that line. Now what you see about these two lines is that they are parallel. Parallel lines will never intersect, so there is no solution to this system of equations because the two lines will never cross. So how many solutions does the system have? It has 0 solutions. Let's look at the third case. In this equation, you can see we have y equals 5x minus 6. We're going to start our graph at -6. 1, 2, 3, 4, 5, 6 down on the y-axis. Our slope is 5 over 1. We're going to go up 5 and right 1. 1, 2, 3, 4, 5 up over 1. Do that one more time. 1, 2, 3, 4, 5 up and over 1. Draw our line. Now, if we look at the second equation here, we have y equals -6 plus 5x. Now, the order of this is different, but we're going to start this graph at -6 because the y-intercept is the number that's by itself with no variable. So we start at -6, and we would go 5 over 1, up 5, right 1, up 5, right 1, up 5, right 1. You see that we actually created the same exact line. Now it looks like there's only one line graphed here, but it's really two lines on top of each other. This means that this has infinite solutions because every point on this line is an answer. So how many solutions does this have? It has infinite solutions. Okay. Now we're going to recap what we learned here. Okay. The solution of a system of equations can be found by locating where the two lines cross or intersect. All right. Now, we can tell by looking at the equation how many solutions it's going to have. It says a system of equations will have one solution if what? Okay. This first one that we did had one solution. You can see that they had different slopes. Okay. If you have different slopes, you will have one solution. Okay. So a system will have one solution if the slope of each line is different. If you have two different slopes, you will have one solution. Now, 0 solutions is when the lines were parallel. What did you notice about these equations? When the lines were parallel, they had the same slope, but a different y-intercept. Okay? So in order to have 0 solutions, you have to have the slope of each line is the same, but the y-intercept is different. Okay. And then the third case, which we just did, is if it has infinite solutions, both the slope and the y-intercept were the same. So in order to have infinite solutions, the slope and the y-intercept of each line are the same. And that's a review of graphing systems of equations.